Hey everyone, welcome to the second part of the quadratic formula video. In this video, we're going to learn how to describe the solutions of a quadratic equation without actually solving the whole thing out. So if you haven't watched the first video for the quadratic formula, I would encourage you to do that first and then come back to this video. So essentially, we want to be able to tell whether our quadratic equation is going to have real or non-real solutions, rational or irrational solutions, equal or unequal solutions before we actually do all of the work. So that's going to be based on the discriminant. If you go back and look at all of the examples that we solved, right, the solution that we got was based on the discriminant. So when the discriminant was positive or negative, right, that told us something about our solutions, right? So let's start there. If the discriminant is greater than or equal to 0, that means we're going to have real solutions, right? Look back at all of the examples that we solved. Anytime we got a discriminant that was 0 or 72, 88, all those had real solutions. The one example where the discriminant was negative 47, that's where we had no real solutions. So that's when the discriminant is negative. Okay, so right off the bat, we find the discriminant. If it's greater than or equal to 0, we know we have real solutions. If it's less than 0, we know we have non-real solutions. Now, how do we know if they're rational or irrational? Well, if we look at those examples that we solved, anytime that the discriminant was a perfect square, we got rational solutions. Anytime the discriminant was not a perfect square, we got irrational solutions. So, rational discriminant is a perfect square, and then irrational discriminant is not a perfect square. And what about equal or unequal? Well, the example where we got equal solutions, x equals 2, to be more particular, if you go back and look, the discriminant was equal to 0. Every other time, we had two different solutions, whether it was 1 and negative 3, right, or any of those different types of solutions. Discriminant equals 0, we had equal solutions. Discriminant not equal to 0, unequal. Okay, so here, discriminant equals 0, and here, discriminant not equal to 0. So we found all that out by just finding the discriminant. So we already knew the discriminant was helpful, right? We saw that in the factoring unit. If we found the discriminant and it was not a perfect square, we knew that we could not factor that quadratic, which makes sense now, because now when we turn it into an equation, it gives us irrational solutions. But now we know whether we have real or non-real, equal or unequal answers or solutions before we even do any of the work. Okay, so use the discriminant of the following equation to describe the solutions. So we have 2x squared minus 2x minus 3 equals 0. Okay, so we're going to find the discriminant. So a is 2, b is negative 2, c is negative 3. So our discriminant then is negative 2 squared minus 4 times 2 times negative 3. So we have 4 plus 24, which is 28. Okay, so we have our discriminant. What could this tell us? So first thing, it's positive. So that means we have real solutions. That's answering that first question. Okay, 28 is not a perfect square. So we have irrational solutions. And it's not 0. So we have unequal solutions. So if we solve this using the quadratic formula, we should find that we have real solutions that are irrational and unequal. Okay, so let's actually do this as practice with the quadratic formula. I know we don't have to. Okay, so x equals the negation of negative 2 plus or minus the square root of the discriminant all over 2 times 2. Okay, so the square root of 48 in simplest radical form, so that's square root of 4 times the square root of 7, which is 2 times the square root of 7. Okay, so that means x equals positive 2 plus or minus 2 times the square root of 7 over 4. Greatest common factor in the numerator is 2, so 1 plus or minus the square root of 7 over 4. So 2 and 4 simplify, gives us 2 in the denominator. So we have 1 plus or minus the square root of 7 over 2. So that means either x equals 1 plus the square root of 7 over 2, or x equals 1 minus the square root of 7 over 2. Okay, so first thing, we definitely have real solutions. We found them, right? We didn't have the square root of a negative number. Irrational, definitely, right? We're adding 1 to the square root of 7, or subtracting the square root of 7 from 1. And these are definitely not equal. They're not the same value, right? 1 plus rad 7 and 1 minus rad 7 are going to be two different values. And then we're going to divide each of those by 2. Okay, so instead of doing all this work to come up with the same answers, we can just look at the discriminant and come up with these conclusions. So that's helpful if we just want to know what the nature of the solutions are, right? If we don't care what the actual solutions are, we just want to know how to describe them, right? Irrational solutions tells us that the quadratic that we have can't be factored, right? That's helpful to know. Unequal solutions, well, that tells us that there's going to be two different solutions. That's helpful to know. Real solutions, that tells us that we have solutions in the first place. Okay, all that information is really helpful to us. So for what value or values of k will the equation below have no real solutions? Okay, so that's going to be based on the discriminant, so let's find the discriminant. So a is 1, b is 5, c is k. So our discriminant then, b squared minus 4ac. So we have 25 minus 4k. Now it's kind of weird, there's a variable in our discriminant, but that's actually exactly what we want. Now, if it's going to have no real solutions, well, what do we know about the discriminant? We know that the discriminant is less than 0. It's negative, right? That's when we're going to have no real solutions. Okay, so let's take the discriminant and set it less than 0. Well, now we just have a single variable inequality to solve, and we've done that before. So we can start by subtracting 25 from both sides. So we have negative 4k is less than negative 25. Divide both sides by negative 4. I'll go over here now. Now remember, when we divide by a negative, we have to switch the inequality sign. So now k is greater than 25 over 4. So for what value or values of k? Well, if you pick any value of k that's greater than 25 over 4, this quadratic equation will have no real solutions. You can try that on your own, right? Pick a value that's greater than 25 over 4. Pick k as 100, for instance, and try to find the discriminant, and you should find that you're going to get a negative discriminant. Okay, so this is just a nice little extension that we can use the discriminant to figure out the nature of our solutions before we actually solve. And they can use this in problems where they give us a missing part of the equation and say, find that missing part if we know something about the solutions. Okay, so now look at a few examples. Don't go too crazy. Definitely want to emphasize the quadratic formula more than the nature of the solutions, but it's a nice follow-up and really shows that you understand what we're doing with the quadratic formula. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.